Okay, and now for video 4F, the real last video for Module 4. Two more examples. Before we get started, remember to balance equations, change the coefficients, not the subscripts. All right, another example. We're going to look at example 4.2. Example 4.2 says to balance the equation of N2 plus H2 yields NH3, which is known as ammonia. That's the compound or the chemical formula for ammonia. Okay, so we have to balance this, so we're going to start by counting up nitrogens on both sides. Nitrogen, for the reactant side, so far we have 2. Nitrogen on the product side, so far we have the invisible coefficient says 1, the invisible subscript says 1, so 1 times 1 is 1, so only 1. So that's a problem, right? That's not balanced. So let's take care of it right away. If we need the nitrogens over here, we need there to be 2 of them. We cannot add or change the subscript, but we can put a different coefficient out front. So if we put the coefficient of 2 out front, now we have 2 ammonia molecules, and within each molecule we have one nitrogen atom, meaning now we have 2 nitrogen atoms. So the nitrogen is now balanced. Okay, next let's take a look at hydrogen. Hydrogen on the reactant side, there are 2 present. Hydrogen on the product side now has, we multiply the coefficient times hydrogen subscript, 2 times 3. So now there are 6 hydrogen atoms on the product side. Okay? Again, we only had 2 over here. We want this to be 6. So 2 times what equals 6? 2 times 3. So 3 is going to be our coefficient that we're going to plug in out front here. Okay, if we have a coefficient of 3 before the H2, that will mean we have 6 hydrogens on the left, matching the 6 hydrogens that we have on the right. So this 2 becomes a 6, and now you can see that the reactants and the products are balanced. And that's how you balance an equation. That was a simple example. We'll try another one. Come in. Did you hear my door? Someone's at the door. They are probably looking for some chemistry lessons. Well, they came to the right place. All right, another example. HCl plus Ca. HCl plus Ca yields CaCl2 and hydrogen. Hydrogen is always present as a twinsy. It's a diatomic molecule, so it's H2. So we're going to start by balancing by looking at the hydrogens, okay? Hydrogen on the left has 1 atom present. Hydrogen on the right has 2 atoms present. So over here, we need this to become a 2. 1 times what equals 2? 1 times 2 equals 2. So we need to put a 2 coefficient out front here. Okay, and just by doing that now we have 2 hydrogens. So this becomes a 2. Okay, so now the hydrogens are balanced. Next, let's look at chlorine. Cl on the left, we have this coefficient, remember, is talking about the entire HCl molecule. So there are now 2 chlorine atoms on the reactant side. And on the product side, the subscript here is only referring to the Cl within the molecule. So there are 2 Cl atoms, 2 chlorine atoms in the product side. And lastly, calcium. Calcium, we only have 1 for the reactants, and for the products, we have also just 1. So that turned out to be a fairly easy example too. The good news is that we will practice many more examples together in class, and you will practice many more examples on your own in your homework. Please email me, my students. You know my contact information if you're having trouble with this, but we will have lots of time and examples to do.